So we are going to learn about VCB control circuit in three-phase locos. Before coming to before coming to the circuit, these are the MCBs associated with the VCB control circuit. This is 3 bar 1, 3 bar 2 for activating cab equipments, because the driver has to operate BLDs on cab. So cab equipments has to be activated. For that MCB 3 bar 1 is there. Then 127.12, this is controlling the VCB circuit equipment, and 9 bar 1, 127.9 bar 1. This is actually control circuit, control electronics MCB. Why this is required, I will explain in circuit. 92 bar 1 and 92 bar 2. 127.91 bar 1, 92 bar 2. This is for LSCG indication, 24 volt supply is required. So that supply is coming through this MCB. So this is our basic circuit. So this is VCB. Okay. What our aim is to, we have to control this from driver desk. How the control is working, I will tell one by one. Here this is the BLDJ switch. So before closing VCB, any one cab has to be activated. Then only BLDJ switch will function. So driver will go to loco, switch on battery, go to loco, he will put BL key to D. Then cab activation contactor will be activated. Cab activation means respective to which cab he is standing. Cab 1 is there means then 126.7 bar 1 will power on. Cab 2 means 7 bar 2 will power on. Okay. Through that interlock, through that this contactor is located in SB1 panel, and this contactor will pick up. Through this contactor, the supply will come to 2111A to BLDJ. BLDJ means in front of driver and switch is there. He has to operate that. Then only VCB will close. So supply will come here. Okay. And before closing VCB, driver has to raise pantograph. Okay, that is understood, na? So he has already raised pantograph. So this contactor, this for panda circuit 130.1, this is already picked up. So this NO is already closed, NC. So supply will come through here, and this is here. Another one BLDJ interlock is there. This switch, single switch is having one NO interlock and NC interlock. NO interlock is used for closing VCB. NC interlock, same switch, NC interlock is used for opening VCB. So for closing VCB, driver will press downwards. Opening VCB, driver will press upwards. Okay. So during closing, the supply will come here. Panda contactor already closed, and this is for rear cab. Rear cab is inactive. So rear cab BLDJ will be bypassed via BL interlock, because rear cab BL is already unoccupied. So here BL switch will be in 0 position. If BL is in 0 position means then this control is inactive. Suppose if rear cab anybody is sitting, he is playing with the BLDJ, then it will unnecessarily create interference with the VCB working. So in order to avoid that, rear cab BLDJ control is bypassed through BL switch interlock, main switch interlock. Okay. So supply will come by here, and this is our same loco BL cab. So here we are putting BLDJ, we have put. So this control is not there. This is open. So again supply will come through here. This is NC. Main important thing we have to understand is that any doubt you can stop. Important thing here that we have to understand is that same switch is having two interlocks, NO and NC. While operating this NO, this NC should not get disturbed. If NC is disturbed means then VC will not close. Separate cab, but same switch. So here our BL key is already we have put. So here this is bypassed through BLDJ switch only. This supply NC interlock only. This supply will come to BVCB disabled. This is actually controlled by VCU electronics. Why this command is given means not only driver, VC itself having protective function. It will decide when to trip VCB. So he should also have some control. So that's why we are giving supply via this card. And if this is disabled, VCB is agreeing to close VCB means then this supply will come to 136.4 contactor. This is so if everything is okay means when we are pressing BLDJ, this contactor should pick up. If it is not picking up means then somewhere here some problem is there. Okay. So first instant, after putting BL key, when BLDJ is pressed, after raising pantograph, that node everything is okay means he has to press BLDJ. Then this contactor should pick up 136.4. Okay. And 136.4 picked up. How for how much time it will pick up? Supply is coming through here BLDJ. So with whatever time driver is pressing BLDJ, that time this will pick up. And after releasing means this will release. Okay. So here if it is picking up means this one in the N interlock is here. That is 0.4. This will close in this circuit. Okay. Where this circuit is coming from? This is another parallel path. It is coming through MCR relay. MCR means over current relay, maximum current relay. If any short circuit is there means this relay will act. So VCB will initially what will happen? VCB will close, but it will not hold. This interlock relay will act and this supply will cut. So even though 136.4 picks up, this supply cut means this interlock is having no supply. So VCB will trip. Another relay is coming in circuit is MVR, that is minimum voltage relay. Minimum voltage relay is nowadays not used in our locos. This is my bus. This relay is used only for monitoring VCB closing OHC voltage during cooling mode. During normal energization mode, this is bypassed with 126.6 interlock. What is 126.6? Rahul, C1. C1 when will it energize? When which position? BL. BL. Whenever BL key is put into D, that is drive mode. Drive mode means this contactor will energize. So drive mode, this relay is already always bypassed. So drive mode, we are not this relay is not in circuit. But in cooling mode, what will happen? C mode we are putting. So this relay will be de-energized and this will be available. Why this is required in cooling mode? Why this MVR is required in cooling mode? What is its purpose? In driving mode, electronics will be in service. Okay. So whether we are taking OHC voltage from voltage supply from OHC, that OHC whether it is having proper supply or not, who is ensuring? Normally electronics will ensure. Okay. So in cooling mode, what will happen? Electronics is bypassed. So there is no monitoring of OHC voltage. In order to monitor OHC voltage, we are using this relay. Okay. So this relay is required only in cooling mode. So what will happen? Now we are talking about the driving mode. This relay OCR, MCR, if it is normal means this NC will be closed. So supply will come here through, already we have put BL key in D. So this will be closed. This supply will come here, 136.4, when it will close? When driver will press BLDJ. So when if I am pressing BLDJ means this is closed. So what will happen? The supply will come here and it is sensed by LVCB on. This signal is called driver wish to close VCB. VCB will sense whether driver is wants to close VCB or not by sensing this signal. If it is high means then it will take us driver is going to driver is wishing to close VCB and it will give necessary commands. Okay, up to this clear. So what will happen? LVCB will be on. Another branch here, the MCR, another parallel branch is going to this card BVCB on pulse. Okay, if this LVCB is on, then this card will give one supply, one pulse. Pulse means only one pulse, 1 second supply to this coil 2326, 2329. 2329 is connected to VCB. This is our VCB. This coil is, this cable is connected to VCB. It is called a closing coil. Okay. So when this LVCB is on means this card VCB on pulse will give one supply 110 volt directly to 2329 and VCB will close. But what I told is that it will give a pulse for only 1 second. But we want VCB to be closed permanently. So how it will close? So here, if everything is okay, LVCB is on means the supply is given after 1 second. Once 2329 gets supply, then VCB will be physically closed. That means its NO interlock will be shifted to NC position. Okay. So inside VCB, one paralleling is there. This wire and this wire. This is called closing supply. 2326 is called holding supply. So these two will be paralleled inside. So once it is closed means then this supply will be coming to here automatically. But during normal working, what will happen? 2329 supply get VCB closed after 1 second. So here another parallel branch is going. Okay, this is our SR1. This is our SR2. Okay. So if everything is okay, everything means OH is okay, VCB pressure is okay, everything is okay means this supply, this 2326 will be given by our SR electronics, SR1 and SR2. So here two processors are shown, STB and HBB. STB is our master processor for VCB control. If STB fail means this paralleling, HB will take care. Okay. So this two supply will come from SR, YSR. After closing VCB, what will happen? This supply will be cut. Then SR, if everything is okay, then SR sensing feedback, everything okay means SR will give 2326 supply to here 5. This is pin number 2 and this is pin number 4. So pin number 2 supply means PCB will close, after 1 second it will cut. By that time what will happen? SR should give permanent supply here. Okay. Why we are going through this SR? Everything is monitored by this electronics, SR electronics only monitoring. If SR wants to trip VCB, then what it will do? It will cut the supply 2326. Then VCB will automatically trip. That's why we are giving command through SR electronics. Okay. Any doubt? Doubt irukka? So what is the signal name for drivers wish to close VCB? Nee parra ninte perna. Idil edana signal? Driver VCB close cheyan aagrahikkunnundu. What is the signal? ഇതിലുള്ള ഏത് സിഗ്നൽ ആക്റ്റീവ് ആയിരുന്നാലാണ് VCB വന്നിട്ട് ഡ്രൈവർ VCB ക്ലോസ് ചെയ്യാൻ ആഗ്രഹിക്കുന്നുണ്ടെന്ന് മനസ്സിലാക്കുക. ഏതാ പറ? ഇതാണോ ഇതാണോ ഇതാണോ? ഇതാണോ 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 അതാണോ? പറ ഒച്ചത്തിൽ പറ. 2312 അല്ല, സിഗ്നലിന്റെ പേര് LVCB ഓൺ. LVCB ഓൺ ആണ് ഡ്രൈവറുടെ വിഷ്. ഓക്കെ. ഇതെന്താ സാധനം? BVCB ഡിസേബിൾ എന്ന് പറയുന്ന സാധനം. If SR is detecting something, then it should not allow driver to close VCB. So driver command is coming via BVCB disable only. If it is high means then this signal will not come to 136.4. So what we will experience? BLDJ closing means 136.4 will not pick up. So we have to check the supply whether it is available here. 2316 whether it is getting supply. 2311 supply available or not. Then we will came to know that this SR is blocking. Then we have to go for further analysis. Why SR is blocking supply? Okay. And here one parallel path is there. What is this use? 126.6 NC. ഇത് പറ, രാഹുൽ പറ, അതെന്താ സംഭവം? കൂളിംഗ് മോഡിൽ എന്താകും? So what we have told here is that during normal working with electronics in service, so our loco is designed to work in cooling mode also. What is cooling mode? When it will be used? നീ പറ, നിന്റെ പേരെന്താ? മഹേഷാ? വിനീത് പറ. അതായത് നമ്മുടെ വണ്ടിയിൽ കണ്ടിന്യൂസ് വർക്ക് ചെയ്തുകൊണ്ടിരിക്കുമ്പോൾ ഇഫ് ടെമ്പറേച്ചർ ഗോസ് ബിയോണ്ട് സം സർട്ടൻ ലിമിറ്റ്, then we have to cool down the temperature of the electronics. For that purpose, what we have to do? We have to give forced air to our electronics. With electronics not in working condition, the electronics should not work that time. Only cooling air should be supplied. For that purpose, we are using cooling mode. Cooling mode vanadu in the electronics edhume vela no control will be there. Only blower will be there. Machine room blower will be there. Through that air will be supplied to VCU racks and SR. Burr work illa. And MRV scavenger matram. Single phase supply. ഇപ്പൊ പ്രീവിയസ് ആക്കി. ഇപ്പൊ കൂളിംഗ് മോഡ് ഇല്ല, അത് പറയുന്നത്. സർക്യൂട്ട് ഇതില്ലേ, ഇത് പറയണ്ടേ? So cooling mode, after reaching a certain temperature, we have to stop the loco and cool the electronics to bring down the temperature to normal level. For that only we are using cooling mode. So in cooling mode also VCB should close now. Then only MRV should work. Cooling mode also we are taking supply from through OHC only. So cooling mode also VCB should close. So cooling mode time, what difference will come here? Pushpendra Vara. Here, what is the difference between cooling mode and driving mode? What difference will come here in this circuit, this branch? Cooling mode, it will close. Okay. Then here, right. This switch will close in both in cooling and driving mode. But in driving mode, this is bypassed. That is only the difference. Cooling mode and driving mode, if the relay is available, means it will close, energize. But this interlock is bypassed through this conductor. That means if any poor contact or sensing, this sensing is not important in driving mode. It will be decided by electronics, whether OH is correct or not. For that, separate sensing is there. So cooling mode, what will happen? This branch is same. 136.4 will pick up. Okay. Then supply will come through here. This is open. Through here, 137 close, LVCB on. ഇത് വരുമാ? അത് വരാது. അപ്പൊ എന്നാകും? இந்த സപ്ലൈ കയറി ഇതുവഴി വന്ന് 126.6 ഇതെന്നത് NO NC. So this will be closed or open? Cooling mode തന്നെ இருக்கும். Closed or open? Closed. So supply will come through here. Here one timer is 136.3. Same supply is given to holding coil also. So initially same supply is used for closing and holding in cooling mode. Only one supply will come, that is used for closing. Initially this will give, timer will give 1 second supply to closing coil. After that this supply, holding coil will get permanent supply. Okay. Any doubt? Cooling mode or driving mode? Cooling mode same supply. This supply is same supply. We holding coil initial closing timer pulse. Driving mode electronics pulse. Electronics 1 second. Automatically time set cut. Cooling mode and the timer permanent supply timer 1 second cut. 1 second VCB close. Close closing supply. Once closed, it is being held by holding supply. So holding supply should be permanent. Okay. In VCB close aisle, after closing VCB, electronics should give some feedback, should get some feedback, and driver should get some indication whether VCB is closed or not. For that, we are using interlocks of VCB. So two interlocks are there. Once VCB is closed means this interlock will be closed. So here supply, after closing, the supply will be sensed by STB and HBB. So both the processor should get the feedback. If any interlock or core contact any one processor is not getting means, then other processor should take charge after tripping. First it will trip, then second closing it will take it. Here LED indication is there, LSDJ. Where LSDJ is located? Where LSDJ? Eh? What is the color? Color of the lamp? Red. Supply voltage? Eh? All indication lamps in driver desk are working with 24 volt. Okay. So 24 volt already here it is coming through. This is coming from DC-DC converter. Already we are having two DC-DC converter behind SB1 and SB2. It will convert 110 to 24 and 48. So with from there we will take 24 supply to all the indication lamps. Okay. So driver, if this is normally what will happen, if VCB is open means this will glow or not. This is coming through which interlock? NO or MC? This is NO or MC? This is NO or MC interlock? NC. NO or MC interlock you are able to identify. Yeah? This arrow, if it is off me or continuity means it is NC. If this block is coming means this is NO. Okay. So this is NC. So normally before closing VCB, what will happen? The supply is coming to our lamp. So before closing VCB, driver will get the indication of lamp LSDJ glowing. After closing VCB, what will happen? This will open. So lamp will extinguish. So after pressing BLDJ, he has to ensure whether LSDJ is extinguished or not. Then only he will confirm that VCB is closed. Here another one interlock is there. 78. 78 where it will come? Here. Okay, it is having two interlock. One NC. NC we are using in VCB control circuit. NO. Another interlock is there. NO it is sensed by STB1 to detect whether OCR acted or not. This interlock we are using only for VCB closing circuit. It will not give any message to driver whether relay acted or not. So in order to give feedback of this relay, another separate interlock is there. It is sensed by VCU. If signal is getting high means then message pop-up will come. DJ will trip and a message will come. As primary current is high. How DJ will trip? Eh? This relay is having one NO and one NC. If NO closing means what will happen? NC will open. NC open means whatever our wish command is cut. Then DC will trip. Okay. So this is not working. Here one timer is there, 136.3. During normal VCB closing, initially there will be an inrush of current because our transformer will not be charged condition. So initially it is an inductive load. So whenever we are giving a 24 high voltage supply, initial inrush of current will be high. After some time it will get stable. So during that time our VCB should not trip. Because how VCB will trip? Through MCR sensing. So MCR should be bypassed during that time. For that we are using this 136.3 timer. Same timer we are using here also, VCB circuit also. One interlock will come here and another interlock will come here. So during initial closing, for 2 seconds, timing is 2 seconds, 2 seconds, this OCR relay sensing will be bypassed. Because during that time, always current will be above our setting. Our relay setting is around 330 amps. So it will go around 750 amps during initial closing. After some time it will stable. It will come below our normal rating. So during that time it has to be bypassed. For bypassing we are using same timer relay in VCB circuit, another interlock. It is bypassing, this is the relay coil. So this timer interlock will bypass the relay. After some time, 2 seconds, what will happen? This will open. So relay coil will get supply and it will continue monitoring. Okay, and this is the sensing by OH sensing by VCU. I have told if in driving mode VCU will sense the OH voltage. How it is sensing? It is this is a PT primary voltage transformer where it is located on the roof. Ratio is 25 to 200 volt. Okay. From there 200 volt come to a PT module 200 to 4 volt. Where it is located? Inside SR. So if this 4 volt is available, then electronics will sense, SR will sense as OH is okay or not. If there is any variation means, then accordingly this will voltage will vary, and here it will sense as OH is not available. Okay. Likewise for SR1 and SR2. Here another PT module is a 200 bar 10 volt. For what this is used for? രാവിലെ പറ ഈ PT module എന്തിനാ എവിടെ so driver panel meter indication will be there என்னென்ன meter TB meter should work. It will work with 10 volt supply. So where the 10 volt will come? Here 200 volt is there. So another PT module is there 200 to 10. You will convert, and this supply will give to our traction bogie meters. Also this 200 volt MBR na already told where it is available. Here MBR will also work with this 200 volt supply. അതിൽ ആക്ച്വലി രണ്ടും വരും 24 വരും ഓക്കെ എനി ഡൗട്ട് ஆக்சுவலி திஸ் விசிபி சர்க்யூட்னா எவ்வளோதான் இருக்குது இது எல்லாமே தியரி தான் வரும் இது ஆக்சுவலாக வந்துட்டு நம்ம மாஸ்டர் ப்ரொசஸர் எது which processor controls VCB in master mode? STB already told na? Here STB is our master processor because processor means our VCU. Which VCU is controlling? STB1 processor is controlling our VCB functions in master mode. Normal working, if everything is okay, means this processor will be in control. If any disturbance to this processor only, this will back up. This is a backup processor. So that is what I told here. STB1 is our dominant processor and HBB is our redundant processor. When redundant will take care, if the dominant processor fails, then the redundant processor will take care. Okay. If the VCB does not close while being controlled from STB1, FLG will switch over to the emergency mode. Emergency mode means it will switch over to other processor. That's all. Then this is a basic idea of our software. How software is written, what protective actions have been designed. Software design for VCB control is divided into 5 parts. First of all, VCB on-off wish generation. Okay, who will generate this wish? Driver. Then collection of VCB on conditions. Then electronics will sense whether the closing conditions for the VCBs have been satisfied or not. All the conditions are satisfied, then only it will allow for VCB closing. How it will allow? For that only we have given command through this VCB disabled. If it is 0 means it will allow to close VCB. If the signal is high means it will block. Then collection of VCB off conditions. VCB control and supervision. During closing time, whether working is feedback is getting or not through axle interlock. That it will monitor. Then if any fault is coming associated with VCB, then it has to be stored for further analysis. So these are the 5 parts of our software design for VCB. Then on-off wish generation. Already told them. Who will generate? Driver. On-off wish logic driver mode is partly hardwired. Why we are saying partly hardwired? Here, the supply, it is decided by VCU. Okay, whether has to be closed or not. Here another one more interlock is there, panda contactor. This panda contactor also VCU will allow whether it has to be closed or not. So these two controls are decided by electronics. So this is software control. Also another branch what here? Here NCR relay NC interlock is there. Then 136.N interlock is there. This is hardware. So partially software logic and partially hardware. So which generation is partially hardware and partially software logic enabled. So what are the conditions to generate wish command? If these are the these four conditions are satisfied, then only it will allow to then our VCB will close. First condition what? VCB disable contactor must be de-energized. De-energized means where is this contactor? Here. So who will control this? Eh? Which component will control this VCB disabled? Eh? VCU, our electronics. So even though driver wishes, with electronics permission only he can close. So this command should be low. Low means then it is you think like a switch. If it is low means the switch is closed. High means switch is open. So it should be de-energized. Okay, first condition. Second, we have to raise the pantograph. Then only VCB will be able to close. So VCB pan wish logic is self-hold mode. Self-hold mode means it is active. 130.1 contactor feedback that electron should get. Then only this contactor will energize. It is controlled by electronics and one N interlock is already placed in our closing path. So Pando, this interlock should be high. Then primary input current is lower than the maximum. Already told parallel path. MCR NC interlock. That should be de-energized condition. And the driver pushes the VCB on version hardware. This is also hardware. BLDJ command should come. That command only given to our VCB disable and 136.4. Okay. If all these four conditions are satisfied, then it will allow to close the VCB. Okay. Then once this logic is active, VCB is ready to close VCB. Then further, if we have to open the VCB or cancel the command. So for cancelling, what are the criteria to be satisfied? First, driver pushes the VCB off push button. Driver wish whether he wants to open the VCB or not. Second, not only this VCB, if Pando switch is also there. Instead of VCB switch, he is downing the Panda also, then VCB should open. Okay. Because for closing and opening also, Panda control should be in there. First, initially Panda should be raised. Then only OHG supply will be there. Then only electrons will be sent. So closing and opening, this command, Panda command is also there, necessary. Then if driver pushes the emergency stop push button. Yeah, what is emergency stop push button? Where it is located? Eh? Where local evidence? Namma madam parayum. Location. What is the use of this BPM switch? Suppose the loco is working in high speed. If any obstruction is, driver detects any obstruction, he has less time to react. So within that time, what he has to do? He has to trip the VCB, lower the pantograph, and apply the brakes. So everything, three actions he has to do. So instead of operating three switches, he has to simply press this switch. All the three actions will be taken care simultaneously. So it is a safety switch provided in loco to stop the loco in case of emergencies. Okay. So where this interlock will come in our circuit? Yes. These are 127.7 bar, 127.12. Our Pando VCB control MCB. through this MCB, this supply. What is this? 2064. Where it will come? 2064. Where it will come? Uh, this is our 2064. Okay. So it is coming via which switch? Emergency switch NC. Isn't that? So our primary supply to maintain the 136.4 interlock or generate LVCB on command, driver wish command supply is given by through this switch only and via emergency switch interlock. So this is already closed, normally closed interlock. If driver pushes means this, then this will be opened. Then what will happen? 2064 will be cut. Okay. Then what signal will be off? LVCB on. It will not get any supply. So it will trip the VCB. Okay. This is the panda logic. I already told. Huh? This 130.1 contactor, one N interlock is there in our VCB circuit. This is also controlled by VCU. So for closing VCB, panda, this condition should be satisfied. Also, MCR, MC should be de-energized condition. So here what we will do? Driver can open the VCB through, if these conditions are satisfied, driver will turn off the BLDJ, panda will be de-energized or emergency push button will be pressed. All the three conditions we can trip the VCB. Okay. Then second, so this is the software design. First part we have gone through which VCB on off which generation. For that, 3 points are there. Then collection of VCB on conditions. If these conditions are satisfied, then only electronics will permit the driver to close the VCB. Driver generates a VCB on wish. That is LVCB on. It should be on already because he has pressed BLDJ. Our 136.4 picked up LVCB on command is high. Okay. Then node, our display master node is there. SR should be, VCB node should be at 560. After 560 only it will allow us to close the VCB. Okay. Then line voltage is okay. Where it will receive this signal from SR. SR is already sensing. I have already told 200/4. That sensing is there. Then pantograph air pressure is okay. Then only this will come. Pando already one command is there. If pando air pressure okay, only then driver will be able to raise the pantograph. 131.1 pickup feedback will be there. So if all these conditions are satisfied, then it is ready to close the VCB. Okay. Then VCB off conditions. Here we have classified it. It has been classified into 3 groups. First, VCB off without disturbance. Normal driver on off. VCB off with disturbance. That means electronics has sensed some issues and it will automatically trip the VCB. Then VCB disabled means any major system has been isolated and it will not allow us to close the VCB. Okay. First, VCB off without disturbance. That means yes, driver wish to be made 0. How it can be made 0? BLDJ off. Then LVCB will be off 0. Then VCB will be opened. Then driver lowers the pantograph. Already known. Driver switches the cab activation key switch into 0. If he is moving, de-energizing the loco, for that what he will do? First BLDJ, then pando, then BL key should be made to 0. If during normal working also, if it is disturbing the BL key, then also VCB will trip. VCB has to trip. So this command is also given. In all the 3 cases, VCB will be shut down without any disturbance message. Normal. This is normal. System will take this as normal. Driver he is doing some command and no disturbance or no fault message should be logged. Okay. Then second case VCB off with the disturbance. Some disturbance is there. How it is sensing the disturbance? If driver pushes the emergency stop push button, this has to be recorded in fault data because he has operated the emergency. Some emergency situation has arisen, or for testing purpose also we will do here, but it has to be recorded. Emergency stop push button is pressed. If one of the processor generated disturbance is the VCB off signal, so both our processors should be working parallel. If one of the processor detects any abnormality or error, then another processor has to be taken care of. So that has to be recorded. Then some of the disturbances are switching of the VCB hardwired. What are the disturbances? MCR/NC 126.NO, 137.4NO. So if any interlock pore contact or disturbance or supply interference means this will trip. So it is a disturbance and it will record. Pantograph air pressure not okay. That then VCB disabled. It will not allow to close the VCB. What are the conditions? If node is lower than 550, so we have to try for closing VCB after reaching MCU node 550. Before that, it will not allow. Okay. Then node 600 and 613. These are shutdown nodes. In that node also, it will not allow. Then 710 and 17 disturbance VCB. These are all failure nodes. So if VCU sensing these nodes, then it will not allow us to close the VCB. Then subsystem 1. Subsystem, what is subsystem 1? Main power circuit. That is SR, transformer, everything. So if any problem is in subsystem 1, there is major sensing is out of order, then VCB should not be closed. Pantograph air pressure, FLG master request is pending. So these four conditions, VCB command will be disabled. System will not allow us to close the VCB. Okay. Then our fourth part is VCB control and supervision. VCB is closed. Then the system should monitor other working also. If any malfunction is or any trouble is there, then it has to trip the VCB. So VCB closing and opening. How it is sensed VCB is closed? Through auxiliary interlock N now. The feedback is coming means it should ensure that it should get the feedback that the VCB is closed. Then it should work. Then if any malfunction is there, then it has to trip the VCB automatically, or VCB disable command will be cut and VCB should be opened. How it is sensing that VCB is opened? Through same interlock only. If it is closed means supply will come. If it is open means supply will not be there. So normal working, this monitoring will be done by our VCU. Then our if any malfunctioning or any trouble, any disturbance is there, it has to store the VCB. Who will store? What is this? Storage of VCB for off reasons. This is our software. Our software already written now. What are the parts available in that software? That only we are discussing. Software design. These are the four parts. VCB on off its generation. Conditions for VCB on conditions are satisfied or not. VCB off conditions. Or it is divided into three parts. Normal, off without disturbance, with disturbance, and VCB disabled. And then control and supervision. Normal VCB closed condition, how VCU is getting feedback and how it is controlling. Then storage of VCB, any fault, how it is being recorded. Now multiple loco. In GNA locos, we used to make multiple units. So multiple units, how command is there. So VCB on off its generation, driver will be available in leading loco. Okay. Generation, which generation is LVCB on will be done in master loco only. This command is transferred via wired train bus to slave loco. So if it is closed means then rear loco also will close, but there is a delay of 0.5 seconds. Signal transmission delay. 0.5. Okay, so always operation and bit generation will be from master loco. Then disturbance. Disturbance means there are two types of disturbance. One, VCB stuck off. Stuck off means what? Driver is trying to close the VCB, but VCU is not getting the feedback that VCB is closed. So that message, so that time what it will show? VCB is stuck off. Stuck off means it is not being energized. Driver is trying to close VCB, but it is not being energized. How it is sensed? Through N interlock. N interlock feedback it is not getting. So stuck off detection, one time delay has been set. So once driver press DLDJ, after 1 second, only this message will come. That means within 1 second VCB has to close and feedback should be sensed by VCU. If this 1 second means 1.2 seconds, then also this message will come. Okay, suppose if any our VCB is having some any interference or any stuck up, so it is moving very slowly. Oscillate switch movement mechanism is stuck, moving very slowly. Then this second will be, this delay will be more. So what will it then? Even though VCB is closed, this message will come. VCB is stuck in off condition. Okay. So if it is detecting that VCB is stuck in off, what it will do? VCB on which will be reset. So VCB is not closing. What will do? It will reset the on command. Once again it will try to give that command through BVCB disable 136.4 interlock. Okay. Then a priority one fault message will be displayed. So it is not closing. So driver should know. So message will be displayed through DDU. Then control of the VCB is changed to the redundant processor. Our STB, what is our redundant dominant processor? STB1. So what is here? What will it do? It will shift the command to HVB. Okay. Then even after shifting to our redundant processor, then also VCB is not closing. Then what will do? Subsystem 1 will be isolated. Okay. This is for VCB stuck in off. That means de-energized condition VCB is stuck. Here VCB is stuck in on. Driver is trying to open the VCB, but VCB is not open. Or not open, how it will sense? Through auxiliary interlock only. For that, how much is the delay? 480 milliseconds. So VCB driver wishes to put off the VCB, then within 480 milliseconds, VCU sends and VCB has been opened. Otherwise, this message will come stuck in on. Okay. So stuck in on condition, what it will do? Converter contactors will be switched off. Both the SR will be isolated. Total load contactor will be isolated. Then message will be shown. Same to here. So subsystem 1 means main power is isolated, loco is set. Okay. Then in ME operation. ME operation already we have told closing command from master loco only. But disturbance and shut will come from slave loco also. So what if there is a disturbance VCB on the master loco, then disturbance is in master loco means then VCB will automatically reset once, because driver is available in leading loco and here it will try to reset the trouble. This will cause a VCB off switch on the slave loco and thereby the VCB open slave loco as well. If any disturbance in master loco, then slave loco also VCB will open. Again, after the fault handling, if driver wants to close means he will close from leading loco, then both the loco will be closed. So tripping will be there. If any disturbance in master loco also, then both the loco VCB will be tripped. Okay. Then slave loco. If any disturbance in slave loco means this command here what will do? Master loco, any disturbance in automatically it will reset the on command. So that automatic resetting will not be there if any disturbance in slave loco. So once this slave loco VCB opens and it will stay in the open position only. അതായത് മാസ്റ്റർ ലോക്കൽ അതിന് ഡിസ്റ്റർബൻസ് വന്നിട്ടുണ്ടെങ്കിൽ VCB ട്രിപ്പ് ആവും. അതിനുശേഷം ഡ്രൈവർ മാനുവൽ റീസെറ്റ് ചെയ്താൽ മാത്രമേ അടുത്ത VCB ക്ലോസിംഗ് സാധ്യമാവുള്ളൂ. പക്ഷെ സ്ലേവ് ലോക്കോയിൽ മാത്രം ഡിസ്റ്റർബൻസ് വന്നിട്ടുണ്ടെങ്കിൽ സ്ലേവ് ലോക്കോ എലോൺ ഈസ് ഹാവിംഗ് പ്രോബ്ലം മീൻസ് then it will automatically try to reclose once. because already in our leading logo VCB is closed. That means LVCB in our leading logo is closed, satisfied. So if rear logo VCB trip means since LVCB in master is high, it will try to close once again. മനസ്സിലായ? ഇത് നമ്മുടെ കേസ് സ്റ്റഡി. ഇതെന്താന്ന് രാഹുൽ പറയും. ഇതെന്താ സംഭവം? This is our auxiliary interlock circuit where it is available. Here இந்த இன்டர்லாக் இதே மாதிரி தான் இருக்கும் பிசிக்கலா. So இது டிஸ்டர்ப் ஆனா என்ன ஆகும்? What will happen? This interlock is disturbed. Then what will happen? Feedback it will not gain. So what VCB will think? VCB is not closed. So fault message what it will come? VCB switch on acknowledgement fault. As per troubleshooting directory, what is this? NO and NC interlock feedback is not getting. So we have to check the auxiliary interlock. Okay. So this auxiliary interlock is very important. മനസ്സിലായ? മനസ്സിലായ? 37 അടുത്ത ഫയല് 37436. ഇതിൽ എന്നാ സൊല്യൂഷനാ? When we are trying to close the VCB, first it is closing, then immediately it is stripping. Okay, then again after second attempt it is closing permanently. So here what was the issue? Initial supply where it will come from? Here it is coming, after 1 second it is going, but holding supply it should come from here, that is not getting. So it was a problem with this 2326 cable. First initially it will close and trip, second time it is closing means it is holding. How it is holding? Because inside there is a paralleling, through that paralleling same supply is giving to this VCB. So closing any issue means we have to check 2326 or 2329, and holding any issue means we have to check 2326. This is a cable number. This is closing supply, this is holding supply. அதுக்கு முன்னாடி இதுக்கு டவுட் உண்டா? ഡൗട്ട് ഉണ്ടോ? ഫസ്റ്റ് ഇത് ക്ലോസ് ആയി, അത് കഴിഞ്ഞാൽ അത് ഹോൾഡ് ആവുന്നില്ല, അത് വിട്ടു. അപ്പൊ എന്താ സംഭവിക്കുക? ഹോൾഡിംഗ് സപ്ലൈ ഇവിടെ വന്നു 2329. അപ്പൊ നമ്മൾ എന്താ ഇവിടെ സപ്ലൈ നോക്കാണ്. ഇവിടെ സപ്ലൈ നോക്കുമ്പോൾ എന്താവും? ഇത് VCB ഇന്റേണലി ഷോർട്ട് ആയതിനെ കൊണ്ട് ഈ സപ്ലൈ തന്നെ ഇവിടെ കാണിക്കും, മൊമെന്ററി ഇവിടെ കാണിച്ചിട്ട് അത് പോവും. മനസ്സിലായി? അപ്പൊ നമ്മൾ എന്താ കരുതിയെന്ന് വെച്ചിട്ടുണ്ടെങ്കിൽ ഈ പ്രോസസറിന്റെ പ്രോബ്ലം ആണെന്നാണ് കരുതിയത്. പക്ഷെ വന്നിട്ട് ഇവിടുത്തെ ഒരു കേബിള് സ്ലാക്ക് ആയിരുന്നു SB-യിൽ, അത് കാരണം ഇത് കിട്ടുന്നില്ല. ഇവിടെ ഒരു ഇമ്പോർട്ടന്റ് ആസ്പെക്ട് എന്ന് പറഞ്ഞിട്ടുണ്ടെങ്കിൽ ദിസ് ടൈമർ VCB ടൈമർ യു ആർ ടോൾഡ് bypassing that MCR relay, so it is being supplied by holding supply. This is not for closing supply ഇതുമായിട്ട് സംബന്ധമില്ല, holding supply. അതായത് കൂളിംഗ് മോഡിൽ വന്നിട്ട് എല്ലാമേ ഒന്ന്, there is no closing, there is no holding, only one supply, cooling mode. டவுட் இருக்கா? சர்க்யூட்ல ஏதாவது டவுட் இருக்கா? கேளுங்க. MU ஆபரேஷன்ல எப்படி நடக்கும்? ஸ்லேவ் லோக்கல் VCB ட்ரிப் ஆச்சுன்னா once again it will try to reset. Why? Because master loco already LVCB command is in on. Master loco if it is stripping means then driver has to reset, then only it will close. These are the main disturbance: stuck in off, stuck in on. Checking off, what is the time duration? 1 second. This 480 millisecond. Multiple control logic. We have driver will command from ready loco. Training loco will close after 0.5 seconds. Same wish is being transferred to training loco via train bus. This is not important. So these are the conditions that you should know whether VCB of disturbance is available, or if disturbance available, what are the subsystems to be checked. VCB disabled, then problem might be in this circuit. Okay, thank you.